So for this last question on WebAssign, this is chapter 10 in the ThinkDO book. We have to really conduct a full regression model on this. So what I'm going to do is I'm just going to copy these numbers and put these into a spreadsheet. So I just selected them all. Let's see here. I think I got a spreadsheet here. Yeah. I just paste them into a spreadsheet. Now I'm trying to predict maximum value of the discount based on the page number in the book, right? So I know page number is X, maximum value is Y. Now there's a lot of calculators out there that'll do this. I'm going to point you towards the Rossman Chance regression calculator because it does it all at once. And we get everything all on one screen. We don't have to go to different calculators. So I'm going to select these just like this. It's important to paste these into a spreadsheet. It's also important to, if you're going to want the graph to have the labels, to make sure that the labels are just one word. Okay, otherwise it wonks it out. So I'm going to select those. I'm going to go to Rossman Chance. Actually, here. Let's see, I think I'll just go this way, that way. So Rossman Chance, and you go to their full website. And if you haven't ever seen this before, you go to the applet collection. And we're going to do our least squares regression equation right there on top. And then I'm going to clear out the data that's there. I'm going to paste the data that I just copied in. I want to use the data, makes the graph. Doesn't look like there's very much association. I see a negative trend, but it's pretty weak, right? They're not clustered. So now how do I get all the values? I'm going to show regression line. That'll give me the regression equation. It's going to show me the correlation coefficient. It's going to show me R squared. Okay, now the only trouble is sometimes WebAssign wants this as a percentage. So you'd have to make that 24.7%. And then so there's the graph. Let's go see if I can answer these WebAssign questions. The other thing I like about this calculator is it uses that we're predicting that maximum hat means it's a predicted value based on the page, and page is our X. One thing I don't like about it is instead of MX plus B form, it's putting it in slope plus, Y-intercept plus slope X form. So but backwards, but statisticians love that for some reason. So I'm going to come back to, let's see, where's that WebAssign assignment? Right here. Let's see here. Let's see. Can I get some of these right? Let's see. Oh, weird that it's acting up like that. Let's see. Might be just because I'm in it as a, here we go. So I'm seeing, that's kind of strange, huh? Certainly not this. Certainly not this. Maybe this. Is there a real outlier with this? 4. Let's see. Let me look at my graph. I've got the 4 in there. So see the difference is the scale they're using. See how the scale goes down from 14, or I guess what's the lowest? The lowest value is 14 up to 20, and they're giving us from 0 up. So let's see. I'm gonna guess that one. I could go back and tweak it. I could go to a spreadsheet, and if I wanted to, I could go here, and I could say, let's insert a chart. Let's see. And it picked out a scatter plot for me, so it was nice and inspired. So I see this here. See how the spreadsheet goes from 0 up. So that tells me I made the right guess here. I was guessing that one. So then part B asks for, what's your regression equation? Well, and this is written in the form slope, y-intercept plus slope. So that the way that the Rossman Chance gave it to me is a nice. Is it nice? Nope, not this one. Let's see here. Let me close this down. Let's come back here. Here we go. So 18.07. Now the only trouble is that going to be enough decimal places? I don't know. Let's find out. 18. And then what's the y-intercept? What is it? Round to 3 decimal places. I might not like it because I don't have 3 decimal places. But we'll see. Can always go into the spreadsheet and do it that way too. 0.0322. I mean, I could while I'm doing this, just because I want to get everything marked right. I could do here in your spreadsheet, I can do equals, and then I can do intercept, just type in the word intercept, see how that pops up. And then you got to make sure you do the Y values, comma, X values. And that gives me a couple more decimal places. So 18.066. Then part C asks for the correlation to 4 decimal places. Well, let's see what Rossman Chance gave me. That gave me the correlation to 3 decimal places. So, well, let's go into the spreadsheet and do what you do to get the correlation. Do equals correl. I mean, I've done this video and I've done this in other videos. Whether you're doing the correlation, you don't have to do the Y first, then the X. I always do, just because that way I'm in the same pattern. So that correlation is negative 0.4974, it looks like. 94 negative 0.4974. And then is it significant? Well, then we got to go pull open that Rossman Chance table, go down to the tables. Of course, you got these in Canvas too. Now I want critical values for the correlation. I've got 9 pieces of data. So 0.66, so negative 0.66 is the negative association. And what do we get for a correlation? No, so that's not statistically significant. I kind of knew that, because when we looked at that scatter plot, I said, there's not much going on here. So we're gonna, even though we get a lousy fit, we're gonna do the prediction. And so what we'll do is we'll say we're gonna substitute in 10 in for X and then 70 in for X. So let me come back here to Rossman Chance, or actually, yeah, let's go back to Rossman Chance. Or I could just use my formula right here. So since I don't have to leave that screen. So what we'll do is, so I'm going to use that equation. First time X equals 10. So 18.066 minus 0.0322 times 10. We'll calculate that. Don't forget to use order of operations. And then 18.066 minus 0.0322 times what, page 70. And we can get that answer. Why don't I stop for a minute and do this calculation? So I did those calculations, and that's what I got for my 2 values. I'm curious about the page 70. Did I have any data points that were out that far? I did. Okay, so that's not a problem. I was just thinking of that example of extrapolation. So there's that. So because I had such a low correlation value, I know there's not significant correlation. So there's no relationship between the amount. If it had been stronger, I could say, sure, it looks like it's going down. But with that kind of spread, with this kind of spread, looking, I mean, there's not much going on there. So we can't say that our prediction is worth much. Let's see here. Come back here to this. Let's see, with part F. Part F says, suppose there are 200 pages. This is what I wanted to do. So I'm going to do that same thing, only I'm going to do with 200. And what I want to point out to you is I don't have a page 200. In fact, the largest page I've got is 100. So who knows if this linear model is going to still be in effect that far away from our collected data. That's an example of extrapolation. So on this last exam, there's a question that I'm going to ask you. Give me a value that's extrapolation. And the way you do it is you make sure you use an X value that's way outside your data. It can be below it. It could be above it. I mean, I could go to negative page, right? I could say, what's the maximum value in negative page, negative 10. That would work, but that wouldn't really work because we don't have negative pages. So using 200, is a good, something really positive here would work because of this situation. Let's see, now I get this set up on my calculator, so I'll be able to do this really quickly. This says it's 11.626. So I'm just going to try 11.63. Okay. And is the least squares valid for 200? No, it's not, because that is extrapolation. And we don't know if that linear model still holds. Actually, it didn't hold back from the low values either because of the low correlation. But that's, I'm looking for you. The one I gave you in the exam has pretty significant linear association. So it would be valid, except because it's correlation, because it's extrapolation, it wouldn't hold. Okay, what's the slope? So the slope is that number that's in front of the X. A couple of you have emailed me about that. So I won't use Rossman Chance. Well, they said 3 decimal places. So here's the slope. And as to the important thing to remember about when you're interpreting what slope means, it's for every unit increase, for every unit 1. So 1 page in this case, the discount increases by about 3 cents. No, it said 3 decimal places, so 0.032 cents. Okay, well, I'm going to take a risk and see how I did. Well, I got all 12 points in that one, right? So that's how you do that last question. It's a little more mathy than the other one, so I'm not surprised it's giving people a hard time. Hopefully this helps you out.